Okay, hi guys. So in this lecture, we'll be discussing on the characteristic of the haloform reaction which we saw in the last lecture. Okay, so characteristic of haloform reaction. Okay, so we have first as that the methyl ketone gives positive iodoform test. Methyl ketone gives positive iodoform test. Okay, second point is acetaldehyde is the only aldehyde which will give positive iodoform test. Acetaldehyde is the only aldehyde which will give positive iodoform test. Okay, third point is that carboxylic acid gives negative iodoform test. Carboxylic acid gives negative iodoform test. We will be seeing the examples as to why we are writing these points down as notes. So this was a general formula of the compound which we took for the iodoform test. So if we take Y as something like this, then obviously it will give iodoform test as CS3 is present here. Okay, 3 moles of I2 will attack here and it will form CHI3, yellow colored precipitate. This will not take place because only 2 hydrogen are available on this carbon atom. Similarly, we'll have HC double bond OH will not give positive iodoform test. No alpha carbon is present on this C double bond O carbon. What will happen in this case? Obviously, yes, it will be giving the iodoform test. Okay, we have CS3 present here. What about this compound? It will not give iodoform test as it is having only 2 hydrogen attached to this carbon atom. Okay, let's see next set of examples. What happens when we place alcohol in NaOI? What will be the product formed? So what will happen? This alcohol will undergo first OH minus would be taken away from H plus, or rather will be taken away by the OH minus or the basic medium. Okay, we'll be getting then something like this. This will again form a double bond with this carbon atom, and as a result we'll have a double bond here, and this H minus or H plus rather would be this has to be a double bond, double for the formation of double bond it has to be a carbocation formation here, hence it will not leave as a H plus, it will leave as a H minus and it will attack on this I. So as a result we'll be getting, this is a electrophile obviously. Okay, partial positive partial negative here. So what we'll have at the end is Hi plus obviously some other side products. Okay, so this is the product which we get if we react alcohol in NaOI presence. Obviously I've said it so many times that alcohols and ethers are stable in basic medium, but in this case we are also adding a electrophile with the basic medium. Okay, hence this reaction goes in the forward direction. Let's look at another example where we have something like this and we are reacting it with again NaOI. You can form the product. Okay, it will be something like this plus obviously Hi. Next example is we have something like ketone plus, let's say we required X moles of I2 plus 5 moles of NaOH for the reaction to take place, and we get CHI3 formed as a yellow precipitate. So how many moles of I2 and Y are required? Obviously 3 moles of I2 are required, as 3 times the electrophile I2 will be getting attacked by negative charged carbon atom or alpha carbon atom here. Again, how many moles of OH minus would actually be required? 3 moles are obviously required for converting CH3 first into CH2 minus and then CH2I, then converting it into CH minus I, and then converting CHI2 into CH3 minus. Okay, 3 moles are definitely required for that purpose, and 1 mole extra mole is required for eliminating CI3 formed on this carbon atom. Okay, or rather this is a double bond only. Let it be double bond only. What will happen is, again for the electrophile OH minus is, or for the nucleophile OH minus is needed for extracting this CHI3 bond from this carbon atom, hence 1 more, hence total 4 is required. Okay, then what about this compound? We need X dash moles of I2 plus Y dash moles of NaOH. Okay, so first this compound has to be converted into a ketone for the haloform reaction to take place in the forward direction. Okay, so how many moles of I2 is required? 1 mole of I2 is required for that purpose. Okay, and how many moles of NaOH is required? 1 mole of NaOH is, or rather 2 moles of NaOH are required. Okay, so in the reaction, if you can see that first mole of NaOH is required for abstracting the H plus from this compound. As a result, O minus will be forming. Okay, and in the second step, where will be the OH minus required? So OH minus will be required when we get HI as a product. OH minus will again act and on this HI, and it will form I minus in the solution. Okay, second mole of OH minus is consumed here, so 2 moles of NaOH are consumed to convert this into ketone. Okay, and from this ketone, haloform reaction will take 3 moles of I2 and 4 moles of NaOH. So in total we will be consuming 4 moles of I2 and 6 moles of NaOH in this reaction. Okay, so let's discuss the last example for this video lecture. So what happens when we reacted with I2 plus NaOH, when we reacted with Br2 plus NaOH, and thirdly we reacted with Cl2 with NaOH. So what would be the rate? Let's suppose this is R1, R2 and R3. The R1, R2, R3 are the rates of this reaction. Okay, so what would be the rate? R1 equals to R2 equals to R3. Why? Because if you see in the RDS does not involve any halogens. Hence, why doesn't it not involve halogens? Because RDS process is, our RDS step is converting first the keto group in presence of OH minus into CH2 minus. Okay, this is the RDS of the haloform reaction. C double bond of CH2 minus. Okay, so in the process of conversion of CH3 bond into CH2 minus, this is the RDS step of the haloform reaction. Hence it is independent of what halogen is present in the reaction, hence rate is equal in all the cases. We can say that rate is, rather I can write it here, that rate is independent of concentration of halogens. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some more examples of compounds which can give positive iodoform test, and then we'll be looking into diazotization of amines. Till then, good luck and goodbye.